is find out the Laplace transform of a sine 3 and cos 2t, right? So here the option A and option B and option C and option D are given. Okay, so here we have to find out the Laplace transform of sine 3t and cos 2t. Okay, and if you want to directly solve with the help of this, and it is very difficult, so we can convert this into a feasible form. So we can convert this sine 3t cos 2t into a feasible form first, then we have to apply the Laplace transform, right? So this is our f of t. So we have to find out the Laplace transform of f of t. So we'll get f of s equal to something, right? So before doing that, first we have to apply, we have to go for trigonometry, and we have to recall our trigonometry equations. We know that 2 sine A cos B is equal to sine of A plus B plus sine of A minus B. We know this equation, right? So now I am converting this sine 3t and cos 2t, so 2 in this equation. So right, but here 2 times is not given. That's why sine A cos B. So sine A cos B equal to 1 by 2 times sine of A plus B plus sine of A minus B. That means this equation, right? Now I am converting this. So sine 3t cos 2t equal sine of A plus B. That means 3 plus 2. That is A equal to here 3t and B equal to here 2t. So that's why 3t plus 2t. How much will get? 5t plus sine of A minus B. That means sine t. Now the Laplace transform of sine of 5t plus sine t. We have to find out this. This is equal to Laplace transform of sine AB. So we know that Laplace transform of sine AT, Laplace transform of sine AT equal to A by S square plus A square. So with the help of this formula, we have to find out the Laplace transform of this. This is equal to 5 by S square plus 25. So here 1 by 2 is there, right? 1 by 2 times, right? 1 by 2 is there. So that's why 1 by 2 times S square plus 25 plus, now the Laplace transform of sine t is what? This will be 1 by S square plus 1. So the option will be 1 by 2 times the 5 by S square plus 25 and 1 by S square plus 1. So if you go for the options, and the option will be here option C. Option C will be the correct answer for this problem. So here first important thing is we have to recall the trigonometric equation, this equation. If you know this equation, the answer will be very simple. Otherwise it is not a simple one.
Is for the JFET circuit shown in the figure, we need to calculate the Q point. That means ID and VDS we need to calculate. For the JFET circuit, current equation for drain current equals to IDSS 1 minus VGS by VP whole square. Here VGS equals to 0 means ID equals to IDSS, which is equals to 12 milliamps. Now the drain to source voltage equals to VDD minus ID into RD. If we substitute the given values 20 minus 12 milliamps into 0.75 into 10 power 3K, then we will get 11 volts for the VDS. Option A is true.
The given matrix is A is equals to 6, 10, minus 2, minus 3. Now we have to find the trace of A power 10. Now first of all, let us see a property. If A is any matrix whose eigenvalues are lambda 1, lambda 2, lambda 3 and so on. Now then trace of A power n will be nothing but sum of all the eigenvalues raised to the power of n. So lambda 2 power n plus lambda 3 power n plus so on. Now in order to find the trace of A power 10, first we have to find the eigenvalues of A. Now in order to find the eigenvalues, we'll consider 6 minus lambda, 10 minus 2 minus 3 minus lambda is equals to 0, which is nothing but the characteristic equation. If we simplify this, we'll get lambda minus 2 into lambda minus 1 is equals to 0, which is nothing but lambda 1 is equals to 1 and lambda 2 is equals to 2. That is, the eigenvalues are 1 and 2. Now according to the property, trace of a power 10 will be lambda 1 power 10 plus lambda 2 power 10, which is 1 power 10 plus 2 power 10. That is nothing but 1025. Option D.
In the given problem, we have to find out the expression available at the output node y. In order to find out the expression for y, we need to know the basic building blocks of CMOS logic for AND gate, NOT gate and OR gate. Those are given like this. For an AND gate, both NMOS transistors are connected in cascade. Then the expression available at the output equals to AB. For an OR gate, both NMOS transistors are connected in parallel. Then the expression at the output of the parallelly connected NMOS transistors is equals to A plus B. For a NOT gate, output is equals to the complement of the input. Using these building blocks, we have to derive the expression for the output y, which is given as follows. These two transistor B and transistor C are connected in parallel. Hence, the relation at the output of this parallelly connected NMOS transistor is equals to B plus C. Again, transistor A is in series with the transistor B plus C. Hence, the output is equals to A into B plus C. Again, transistors A, B, C are in parallel with transistors D, E. Hence, it acts as a OR gate. The configuration before the node Y is acts as a NOT gate. Hence, the output is equals to Y equals to A into B plus C plus DE whole bar. Answer C.